All right, you're welcome again. Today, let's consider numerical analysis. And under numerical analysis, we're going to talk about Muller's method. Okay, now let's take a look at this question. Use Muller's method to seek for the values of x for which the function equals 0. F of x is equal to 2x minus log x minus 6, where x naught is equal to 3, x1 is 3.5, and x2 is 4. Okay, now let's go. Under Muller, we have this formula. Xn plus 1 is equal to xn minus 2c all over b plus or minus square root of b squared minus 4ac. Okay, so this is the formula for Muller's method. Muller's method. So here we have xn plus 1 is equal to xn minus 2c all over b plus or minus square root of b squared minus 4ac. So this is the formula for Muller's method. So, as you can see here, we need a, we need b, we need c. Okay, in order to find the values for the respective x1, x2, x3, x4, x5, and so forth. So under Muller, we have three starters. So with these three starters, that's what we're going to use to find the next value, which is x3. So in this formula, we have xn plus 1 is equal to xn minus 2c all over b plus or minus square root of b squared minus 4ac. So we are going to find the values a, b, c. Then we bring it back here and then we solve. So look at what we are going to do. Please pay attention. It's very simple. We have our starters x0, x1, and x2, right? Good. So look at this formula. We have x0 is equal to, we are going to have a open bracket x0 minus x2. Here we have x1, x0, x1, x2. So the first minus the last, the second minus the last, first minus the last, second minus the last, and then the last minus last. Look at what I'm trying to say. Here, the first one is x0. So we are going to have f of x0, and it's going to give us a open bracket the x0 minus the last, which is x2 in bracket squared, plus b, repeat the same thing again, x0 minus x2, then plus c. Do you see this? Please, it's very simple. I want to, these just the two formulas you are going to use in this Muller's method. The two formulas, these are the only two things you need to know. Okay, so the rest you can just do everything by yourself once you are able to figure out these two formulas. So here we have x0 is equal to a open bracket x0 minus x2 in bracket squared plus b open bracket x0 minus x2 plus c. Then the next one we have x1. So we have f of x1 is going to give you a open bracket x1 minus x2 in bracket squared plus b open bracket x1 minus x2 in bracket plus c. Then the next one we have f of x2. So we're going to have f of x2 is equal to a open bracket x2 minus x2 in bracket squared plus b open bracket x2 minus x2 in bracket plus c. Now look at this last one. When you say x2 minus x2 only give you 0, 0 squared 0 multiplied by a 0, then plus The other side, x2 minus x2, 0. 0 multiplied by b, 0. So here, under this last one, f of x2, we can see clearly that f of x2 is equal to c. F of x2 is equal to c. So in this place where we have c, you can replace them with what? F of 2. You can replace them with f of 2. So now, you see this equation we have now. This is what we are going to use to find our a, b, and c. Already, we say that f of x2 is our c. That means we are simply going to, from the function we have f of x, which is 2x minus log x minus 6. Now, we replace x with what? The value for x2. That means we are going to have f of x2. So when you evaluate for f of x2, using the function you have and the value of x2 is going to give you the value for c. So that means the only thing remaining is a and b. Hello? Do you understand what I mean? So here, we automatically have figured out what is the value for c. So we are going to use the above formula, these two formula, f of x naught and f of x1, to find the value for a and b. To find the value for what? A and b. So when we are looking for this formula or the value for a and b, we have different approach. We have what? Different approach. There is a formula for a and there's a formula for b. So but that is stressful, you memorizing those formulas and all of that. So we are going to use a very simple method to find the value for a, b, and c. So you don't need to memorize any formula. Okay, so that is the reason why I don't want to use that method where you have a is equal to mene mene, b is equal to mene mene. No, I don't want that. Okay, so no need of you cramming or trying to figure out those formulas. So but if you need those formulas, is gotten from matrix. You can use matrix to find the solution to linear simultaneous equations. Okay, now you see that in this place now you have two linear equations, right? So when you try to use matrix method, under matrix determinant method, then you are going to find the formula for a and then the formula for b. So that is exactly what happened there. You can try it on your own, then you get to understand what I'm trying to say. But I don't want us to use that method. So look at what we are going to do. In this formula, we have f of x naught is equal to a open bracket x naught minus x2 all the bracket squared plus b open bracket x naught minus x2 close bracket plus c, and then f of x1 is equal to a open bracket x1 minus x2 in bracket squared plus b open bracket x1 minus x2 in bracket plus c. So in this place, you will know that c is f of x2. So we are going to write f of x2 there. And then that means the only work we need to do now is to find f of x naught, find f of x1, and find f of x2. We already know x naught, we already know x1, and we already know x2. So we are simply going to find their functions, f of x1, f of x naught, and f of x2. So when we find it, we bring it to this equation and evaluate. We are going to obtain our a and b. Let's see what I'm trying to say. F of x is what? 2x minus log x minus 6. Isn't it? Let's find f of x naught. The values we have x naught is 3, x1 is 3.5, and x2 is 4. So let's find f of x naught. So for us to find f of x naught, we have f of x naught is f of 3.0 or 3, which is equal to, in the function we have 2 in the place of x, 3.0 close the bracket, minus log in place of x 3.0, then minus 6. So when we evaluate this, we are going to see that f of x naught is equal to minus 0.4771. So when we evaluate, we see that f of x naught is minus 0.4771. We also go for f of x1. We know that x1 is 3.5, and we know our function to be 2x minus log x minus 6. So let's plug it inside the function. When we say f of x1, we are talking about f of 3.5. So that means we're going to have 2 open bracket 3.5 minus log 3.5 minus 6. So when we evaluate this, it's going to give us 0.4559. Therefore, we see that f of x1 is 0.4559. Good. Lastly, let's evaluate f of x2. We know that x2 is 4. So, and our function f of x is 2x minus log x minus 6. So let's see that f of x2 is f of 4.0. That means we're going to have 2 open bracket 4.0 minus log 4.0 minus 6. When we evaluate this, we are going to see that f of x2 is 1.3979. f of x2 is 1.3979. Good. Now, look at the equation we have, where we say f of x naught is equal to a open bracket x naught minus x2 a bracket squared plus b x naught minus x2 close the bracket plus c, and then f of x1 is equal to a x1 minus x2 in bracket squared plus b x1 minus x2 in bracket plus c. So now we know x naught x1 and x2, and we just found f of x naught, f of x1, and f of x2. Let's bring it all together here. In the first equation, where we have f of x naught, and we say that f of x naught is minus 0.4771. So that means we're going to have minus 0.4771 is equal to, we have a open bracket x naught minus x2 is 3 minus 4 close the bracket squared plus we have b x naught minus x2 is 3 minus 4, then plus c, and we say that c is f of x2. And what is our f of x2? F of x2 is 1.3979. So here we have plus 1.3979. Let's evaluate. So when you evaluate this, you are going to see that a minus b is equal to minus 1.8750. Hello. So when we evaluate this, we see that a minus b is equal to minus 1.8750. We call this equation 1. Now let's go again to f of x2. F of x1. In this case, we have f of x1 is equal to a open bracket x1 minus x2 in bracket squared plus b x1 minus x2 close the bracket plus c. Let's put in what we have. F of x1 is what? Is 0.4559. We say is equal to a open bracket x1 is 3.5 minus x2 is 4. So here we have 3.5 minus 4 in bracket squared plus b x0 x1 minus x2, and then which is the same 3.5 minus 4 plus, you still remember that our c still remains f of x2. So here we have plus 1.3979. Again, when we evaluate, we're also going to see that 0.25a minus 0.5b is equal to minus 0.942. Are you wondering how we got this? When you say 3.5 minus 4, what will it give you? We're going to have minus 0.5, and minus 0.5 squared is 0.25. Are we together? Yes, that is why we have 0.25a minus 0.5b is equal to minus 0.942. We call this equation 2. Now we can actually bring together this equation 1 and equation 2, which has become simultaneous linear equation. So here we have a minus b is equal to minus 1.8750, and then equation 2, 0.25a minus 0.5b is equal to minus 0.942. So solving these two equations simultaneously, we obtain that, or we have that, a is equal to 0.018 and b is 1.893. Hello, we see that a is equal to 0.018 and b is 1.893. You remember that we have found what c is earlier, and c happens to be f of x2, and then c is what? 1.3979. So in this formula for Muller's method, where we have xn plus 1 is equal to xn minus 2c all over b plus or minus square root of b squared minus 4ac. And then here we see that we know our a, we know our b, and we know our c, isn't it? Yes. And then, look at it. We have x1, x0 as our starters, x0, x1, and x2, right? Good. So that means that our the numbers n is going to start from the last starter. It's going to start from the last starter. I don't know if you understand. So if we have one starter, which is x0, the n is going to start from that naught, which is 0. So in this case, we have three starters: x0, x1, and x2. So our n is going to start from 2. Our n is going to start from what? From 2, the last starter. Good. So here now, if our n is 2, in this formula, what are we going to have? We're going to say that when we say 2, n is 2, that means we have 2 plus 1, which is 3. We have x3 is equal to, in this place we have xn. We say that n is 2. We have what? x2. So we have x3 is equal to x2 minus 2c all over b plus or minus square root of b squared minus 4ac. Are we together? Yes. So I'm very sure that from here we know what x2 is, we know what a is, we know what b is, and we know what c is. Now look at it. Let's go. We have x3 is equal to, our x2 is what? 4.0. Then we have minus, we open bracket, 2 times c. What is c? c is 1.3979. So we have 2 times 1.3979 all over. The next one we have b. b is 1.893. Now look at it. We have plus or minus. Plus or minus in mathematics is either plus or what? Or minus. You can't perform these two operations at the same time. No. So what do we do? What is the condition for choosing either plus or minus, positive or negative? Now the condition is b. Look at the value for your b. The b that you obtain. If it is positive, we are going to go with positive. And if it is negative, we are going to go with what? Negative. Hello. Now here we have b plus or minus. B plus or minus. Now we are asking a question. What is the condition when to use plus or when to use minus? And then we say you look at b. The nature of b determines the nature or what the sign we are going to use. If b is positive, use positive. And if b is negative, use what? Negative. Are we together? So here we see that b is what? Is positive. 1.893. So in this place where we have plus or minus, it's either plus or minus. So here now we see that our b is positive, so we're going to go with positive, which is plus. So we have 1.893 plus square root of b squared. We have 1.893 in bracket squared minus 4ac. We have minus open bracket 4 times a, which is 0.018 times c, which is 1.3979. Hello. Yes. So when you evaluate this, we are going to see that in your numerator, where you have 2 times 1.3979, we're going to have 2.9, we're going to have 2.7958 all over. In the denominator, when you simplify, we're going to have 1.893 plus 1.8662. Hello, are we together? And then when you combine it together, here we have 4 minus 2.7958 all over 3.7592. Now when you simplify, you're going to have 4 minus 0.7437. So at the end of the day, we see that x3 is equal to 3.2563. Hello. So using the Muller's method, we found out that x3 is equal to 3.2563, and this is just the first iteration. This is just the what? The first iteration. So if you want to continue your iteration, how are you going to do it? Now look at it. Here we have x0, we have x1, we have x2, and we have x3. So before that, we don't have x3, where we just have x0, x1, and x2. We form a formula, f of x0, f of x1, and f of x2, right? Good. So but in this case now, we have x3. So what are we going to do? So we are going to eliminate x0. Hello. We are going to eliminate what? x0. So in the new formula we are going to have in this f of, right, is going to be f of x1 instead of f of x0. We are no longer working with x0 again, right? Good. So we are going to have f of x1 is equal to this f of x1 minus the last one we have now, which is x3. Hello. We are going to have f of x1 is equal to a open bracket x1 minus the last one, which is x3 close bracket squared, plus b open bracket x1 minus x3 close bracket plus c. Then we go further, we say f of x2. So f of x2 is going to give us a open bracket x2 minus the last one, which is x3 close bracket squared, plus b open bracket x2 minus x3 close bracket plus c. And then the last one, f of x3 is going to be a open bracket x3 minus x3 close bracket squared, plus b open bracket x3 minus x3 close bracket plus c. Okay, so when we say x3 minus x3, what is going to give you? It's going to give you 0. And then we see that f of x3 is equal to c. So in this case now, for us to find another a, b, c, so that we continue the iteration, we see that c here have changed to be f of x3. So the way we did, we found f of x1, f of x2, and f of x3. It's still the same thing we are going to do here. But in this case now, we already know f of x1, we already know f of x2. So the only thing we're going to do is to find f of x3. So when you find f of x3, then you replace the c with f of x3, and then perform the operation x1 minus x3, x2 minus x3, and x3 minus x3, which you have done. Then from here, we are going to find your a, b, and c. So when you find your a, b, and c, Then you go to the Muller formula and then insert the values. We are going to find the next iteration. Are we together? Yes. So therefore, this is how to solve Muller's method. That is how to solve numerical problems using Muller's method. All right. Yes. Thank you very much for watching. Please, if you are new to our YouTube channel, do well to like, share, and subscribe if you have not, and stay blessed. Thank you. Let's take more examples.